Hello students, for class 9 chapter 5 Introduction to Euclid's Geometry. In this video I am giving you solutions of NCERT exercises. But before that, a student must note very carefully how the answers are done according to the question. First, read the question. Question number 1. Which of the following statements are true and which are false? Give reasons for your answer. Question number 1. First question is, only one line can pass through a single point. This statement is false. As we know that infinitely many lines can be drawn through a point. I am showing you, say this is the point. Through this point we can draw infinite number of lines. So infinite number of lines can pass through a point. That is why the statement is false. Second, there are an infinite number of lines which pass through two distinct points. This is also false statement. It is because only one line can pass through two distinct points. That is, if A and B are two distinct points, then through AB only one line can be drawn. So only one distinct line can pass through 2 points. Now the third question. A terminated line can be produced indefinitely on both the sides. It is true. It is because if we consider only AB, then this is called line segment. Now this line segment can be produced to this direction up to infinity, can be produced to this direction up to infinity. So a terminated line can be produced indefinitely on both the sides. Hence the statement is true. Now the fourth statement. If two circles are equal, then their radii are equal. This statement is also true. It is given, if two circles are equal circles will have same radii. From the relation pi r square, that is, it is because, let us assume that area of the first circle is pi r1 square and that of the second circle is pi r2 square. Now from both sides pi cancel. This implies r1 square is equal to r2 square. This implies r1 is equal to r2. That is, if two circles are equal, then the two circles have same radii. Now the fourth point. We are given a figure. You see the question? In the figure, it is given that AB is equal to PQ. There is the line segment AB is equal to line segment PQ, and line segment PQ is equal to line segment XY. Then AB is equal to XY. This statement is true. It is because AB is equal to PQ and XY is equal to PQ. What we know, things which are equal to the same thing from Euclid's axiom, things which are equal to the same thing are equal to each other. In that sense, AB is equal to XY. Now question 2. Give a definition for each of the following terms. Are there other terms that need to be defined first? What are they? And how might you define them? Parallel lines. Now what are parallel lines? Two straight lines are said to be parallel if they do not have any common point. It means if the two lines are extended or produced in both the directions and they never intersect, then the two lines are said to be parallel lines. Next, perpendicular lines. Two lines are said to be perpendicular if angle between the two lines is 90 degrees. Next, third, line segment. Now what is the line segment? A line with two endpoints. A line with two endpoints is a line segment. Now radius of a circle. What is the radius of a circle? The line segment with one endpoint at the center and the other at any point on the circle. That is, if this is the circle and this is the center of the circle, then if a line segment is drawn in such a way, one end is at the center and the other end is on the circle, then this line segment is called radius of the circle. Then square. A quadrilateral with all sides equal and all angles right angles is a square. Okay, now third question. Consider two postulates given below. Number 1. Given any two distinct points A and B, there exists a third point C which is in between A and B. And the second postulate is there exist at least 3 points that are not on the same line. Do these postulates contain any undefined terms? Are these postulates consistent? Do they follow from Euclid's postulates? Explain. Okay. Now let us listen. The explanation. In postulate 1, in between A and B, in between 2 points A and B, remains an undefined term. In between A and B remains an undefined term which appeals to our geometric intuition. There is in between A and B, this is one undefined term. And for this we need one geometrical explanation. The postulates, the two postulates are consistent. Means they are correct. The two postulates 1 and 2 are consistent. Means they are also correct. They do not contradict each other. Both of these postulates do not follow Euclid's postulates. However, they follow the axiom given below. What is the axiom? Let A and B be a straight line. There are infinite number of points composing this line. Now let us choose any except the two ends, that is A and B. We can choose any point in between A and B. This point lies between A and B, and the postulate is right. Now for the second one, if there are only 2 points, they can always be connected by a straight line. Therefore, there have to be at least 3 points for one of them not to fall on the straight line between the other two. It means that if these A and B are two distinct points and AB a straight line, then there occurs a question, collinearity and non-collinearity. For this, a third point is needed. Say C. If C occurs in between A and B and falls on the line, then ABC are collinear. And if C is any other point, but it does not fall on AB, then ABC are not collinear. That is, from these 2 points, we get the idea of collinearity and non-collinearity. Now question number 4. If a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to half of AB. Okay. What we have, AC is equal to BC. What we are doing? Adding AC to both sides. Adding AC to both sides. So AC plus AC is equal to AC plus BC. Now AC plus AC, this is 2AC. And AC plus BC, AC plus CB is equal to AB. So what we get? 2AC is equal to AB. That is, AC is equal to AB by 2, that is half of AB. So it is proved. Now the fifth question. In question 4, that is, this question is related to question 4, point C is called the midpoint. Of course, point C is the midpoint. Now point C is called the midpoint of line segment AB. Prove that every line segment has one and only one midpoint. That is, a straight line cannot have more than one midpoint. Okay. Let there be 2 such midpoints, C and A. These are called the contradictory proof. We assume that for a straight line, 2 midpoints are possible, that is C and D. Now from the midpoint theorem, that is, we have already proved if C is the midpoint, then AC is equal to AB by 2. If C is the midpoint of AB, then AC is equal to AB by 2. What we have assumed? C is the midpoint of AB. Therefore AC is equal to AB by 2. And D is also the midpoint of AB. Then AD is equal to AB by 2. Then AC and AD both are equal to AB by 2. That is AC is equal to AD. Now AC is equal to AD. This is only possible. This is practically impossible. This is possible if C and D coincides. That is, C and D are not two distinct points. They are the same point with two different names. Therefore, C is the unique midpoint. Now, question 6. In figure, if AC is equal to BD, if AC is equal to BD, it is given. Given that AC is equal to BD, we have to prove that AB is equal to CD. Okay, now let us see the proof. What we are given, AC is equal to BD. Subtracting BC from both, that is AC minus BC is equal to BD minus BC. That is, if same thing is subtracted from the equal things, the remainders are equal. Now AC minus BC, what remains? AB. So AB. And BD minus BC, what remains? CD. So CD. That is, AB is equal to CD. Now question 7. Why is axiom 5 in the list of Euclid's axioms considered a universal truth? Note that the question is not about the fifth postulates. It is about the fifth axiom. Now axiom 5, let us recall. Whole is always greater than its parts. Whole is always greater than its parts. This is the fifth axiom. Now let us explain this to show that this is universally true. This is universal truth because parts is included in the whole, and therefore can never be greater than the whole in magnitude. That is why whole is always greater than the parts. Now exercise 5.2. Textbook exercise 5.2. How would you, question number 1, how would you rewrite Euclid's fifth postulate so that it would be easier to understand? When two lines, that is, in this postulate, fifth postulate, we get the idea of parallel lines and intersecting lines. If the statement is stated in this way, if the postulate is stated in this way, that is, when two lines are cut by a third line, when two lines are cut by a third line, say the two lines are AB and CD, and it is cut by a third line, say PQ, such that the sum of interior angles is less than 180 degree. Sum of interior angles is less than 180 degree on one side, there is to this side, the sum of interior angles to the same side of this line is less than 180 degree. Then the first two lines intersect on the same direction. It means now if these two lines are extended, produced, they must intersect in this direction, to which side the sum of the interior angles is less than 180 degree. So this is the fifth postulate. If this postulate is stated in this way, it is easier to understand. Now the second question, does Euclid's fifth postulates imply the existence of parallel lines? Explain. Of course, from Euclid's fifth postulates, we get the idea of parallel and non-parallel lines. It may be argued that Euclid's fifth postulates recognizes the existence of parallel lines. If the sum of interior angles is 180 degree on both sides, that is AB is a straight line and CD is another line, and this is the third line PQ intersecting the first two lines. Now if it is that the sum of interior angles to the same side of the transversal is equal to 180 degree on both sides, then the lines will not intersect on any side if they are produced. So if two lines never intersect, they are parallel. Thus from Euclid's fifth postulates, we get directly or indirectly, basically indirectly, the idea of parallel lines and non-parallel lines. Okay, student.